All right, good morning, guys. Give me a thumbs up if you can hear me. If you can hear me and see me, give me a thumbs up in the chat box, or just want to make sure you can hear and see me. Audio and visual is good. Cool. Ian can hear me, see me. Ben's good. Morgan's good. Yeah. Well, good morning and welcome back to virtual learning after spring break of your senior year. Man, know that I guess I should start by saying, know that I'm praying for you guys every single day. Hoping that we can get back. I know some of you guys have given up hope that that we go back in May. But just know that my hopes is, and I hope that I get to see you again at least one time in the classroom um, before we graduate. Okay, but obviously we're getting near the end here, especially of AP classes, because AP naturally we were supposed to end by May 5th. That's just in a couple weeks, but since they moved that testing time to May 12th, it has changed a little bit with what we can do. And Miss Jeffries asked AP teachers to kind of develop a plan and send out to students and parents of what we can kind of expect going forward, in hope for you guys to help make your decision of, hey, am I going to take the exam? Am I not going to take the exam? I'll start by saying I simply respect whatever decision you want. But for the past 7 or 8 months, you guys have been grinding in this class, and I commend your hard work. There were some days, you didn't feel like doing it, and you did it anyway, so I commend you for that. But real quick, I would just like to review that plan on video on here so you can see it. Now, if you wanted to share it with your parents, I know this is, it's kind of a financial thing too. $90 to pay for this test. It's a pretty big deal. So that's why I shared that with your parents. I shared it with you. Give me a thumbs up to make sure you did receive that informational sheet. Give me a thumbs up that you got that in your email. Okay, cool. So real quick, guys, I'm going to share my screen with you. It's going to look crazy here for a second, but just bear with me. Okay, so just to recap what the email sent out, I was going to talk with you guys about this today, but Ms. Jeffries asked that we'd go ahead and just send some information out as well. So real quick, just a couple of things. First thing is the test date. The test date is Tuesday, May 12th, 2020. The test time is at 2:00 p.m. on that Tuesday, and you need to access the testing system at 1:30 p.m. Okay, so don't plan on getting on there at 2:00 and being able to test. Okay, I don't know what that would look like, but I'm going to urge you guys to be on there at 1:30. Okay, that's what the College Board is saying. You are able to take the exam from any device you have access to, whether it be a computer, a tablet, or even a smartphone. You will be able to either type and upload your response or write responses by hand and submit a photo via your cell phone. We'll talk a little bit more about that here in a minute. You must and again, I put this reminder out to you. You must access the online system 30 minutes before the exam to start to sign up, and that's of course at 1:30. And then, as some of you already know, all 2020 AP exams are open book and open notes. So you have access to everything we've done. At the end of this, it'll be all 30 lessons, 30 chapters, whatever you want to call them. You'll have access to all of that. In late April, So here in the next week or so, the College Board will provide AP students and teachers with information on how to access the testing systems on the test day and video demonstrations so that students can familiarize themselves with the systems. All right. So this is my preparation for the test. On April 30th, as you've seen on the calendar, we will complete our material for AP Calculus. Okay. April 30th, we're going to be done. All right. From May 3rd until May 11th, we will take 5 practice exams that are in the same format of the 2020 revised test. So we'll get to more of that here in a minute, but there's 2 parts to the test. The first part you have 25 minutes for. The second part, or part B, I assume it's going to be a part A and part B. So part A, you're going to have 25 minutes. Part B, you're going to have 15 minutes. And again, we'll talk more about that. So I have 5 practice exams that are in that format. And we'll see the schedule below here in a minute. So I will create a binder with the test to give each of you. Okay? Binders can be picked up at the school starting Monday, April 27th. I don't know if you guys are on the fence about it, or if you guys are totally gung-ho, I'm not taking this, or I am taking it, or whatever. But surely something by Monday, April 27th, you should be able to tell me at least a little something. I don't know when the money's due. I don't know when you have to tell the school. I'm not sure about all that. I saw the email you all got, but I'm not 100% sure on all that as far as that. I urge you guys to take the test because you did spend 7 to 8 months grinding in it. So why not check it out? I know there's a cost to it. If I could cover the cost, trust me, I would for you guys, just for you guys to take it. But continuing on, the school is open from 8 a.m. to 4:30 p.m. Monday through Friday. So starting on that Monday, you'd be able to pick that up anytime from 8 to 4. After each practice test, there will be a YouTube live session over the test discussing the answers and to answer any questions or clear any confusion. Yeah, we'll talk more about that here in a minute. For additional help, the College Board is putting out review videos on YouTube for AP Calculus AB. They can be found by searching Advanced Placement in YouTube and going to the Math and Computer Science section. Other information from the College Board about AP Calculus. Let me zoom in probably a little bit more here. Other information, and guys, I brought this directly from the AP site. I sent you all that link with all that information in Canvases before spring break, just so you can kind of see. So here we go. Exam timing. Students will have 25 minutes to read and respond to question 1, and then 5 minutes to upload their response. Understand that question 1 is probably going to be multiple prompts. So it's going to be like question 1, part A, part B, part C, part D, part E. Okay? So, and that's the way the practice tests are preparing you as well. There's multiple prompts within the question. So, question 1, you're going to have 25 minutes to answer all those prompts. And then I guess it's going to take the question away from you. And then you got 5 minutes to upload it. 5 minutes to upload your question. Again, AP's coming out with more videos explaining that procedure here at the end of April. So, hopefully sometime soon. Then after uploading question 1, you then have 15 minutes to respond to question 2. And then at the end of question 2, once you have all your answers, you can either type them in within the 5 minutes, or you can you could have them all written out on paper, and then you just have 5 minutes to kind of upload that. I urge you to use the full 5 minutes just to check stuff, just to review stuff, make sure everything looks clean and everything's clear and concise. All right. Once the response to question 1 had been submitted, they cannot go back. So again, question number 1. You get 25 minutes. Question 2, you get 15 minutes. Question 1 is 60% of the test, and question 2 is 40% of the test. They are both free response questions. Multi-focus, so that's telling me if it's multi-focus, they're going to be saying, hey, what's the derivative? What's the antiderivative? What is this of that? So you could be looking at a lot, obviously a lot of parts within these two. Okay. Question description. This question will assess students' knowledge and skills developed in 2 or more of the eligible units and topics. So again, telling you it's going to be multi-part. This question will assess the knowledge and skills developed in 2 or more of the eligible units. We're going units 1 through 7, which is what we'll cover. They're not doing unit 8. Okay, they're taking unit 8 out. I didn't think that was much helpful to you guys. So question 1 will consist of similar components to the traditional AP Calculus exam questions with minor modifications to enable students to choose to submit either typed or handwritten responses. Same thing for question 2. Other course specific, for students who prefer to type their responses on computer rather than handwriting and photographing, we will provide a keyboard tip sheet in advance of the exam with suggestions on how to enter various mathematical expressions on a regular keyboard. I think this is going to this is going to be a challenge area right here for you guys. I think this is going to be a little bit, they're going to give it to you in advance, but then you're going to have to go from the tip sheet to your keyboard to figure out what it is and then go from there. That sounds a little risky to me, okay? Because if you can't get something quite right, I don't know how easy it's going to be. I assume they're going to make it, stupid proof, but I don't know how easy that is. To me, it's just so much easier to write the answer and take a picture. Again, I can't really advise you one way or the other. I can just encourage you one way or the other. Questions on the 2020 AP Calculus AB exam are designed as such that a graphing calculator or other calculator is not required. However, use of a calculator is allowed. So you don't need it, but I'd keep it right there by you, especially knowing some of you guys how you want to type in 2 times 2 is 4, just to make sure it's 4. Okay? Going on, no arithmetic or calculations will be required beyond what can be readily be done with pencil or paper. As always, AP Calculus AP students are advised to submit unsimplified numerical answers in order to avoid risking arithmetic errors not related to calculus. So an unsimplified numerical answer. So that, again, now that doesn't mean you don't simplify something in order to get the right answer. Okay, that doesn't mean don't simplify a derivative in order to find x equals a number, which, sometimes you have to, sometimes you don't. But that means if you have like 4/8, if you accidentally said 1/3 on there, you would get the question wrong. They said just don't simplify it. Keep it as unsimplified, okay? Just to keep you from getting a wrong answer. Moving on to our schedule. This would be the schedule for the next couple of weeks, okay? So here we are today in YouTube Live at 1 o'clock. We're going over 27 notes. Please make sure you turn in all work by 4 p.m. via option 1 or option 2 based on the email I sent to you on Monday night. Option 1 is to turn it in at the school. You all saw that I sent out that picture. You can drop it off. I went there on, I think, Tuesday, and a bunch of you guys had already dropped it off, so I appreciate that. If you don't drop it off, send it to me as a PDF, as one PDF with everything on there. We continue throughout every Tuesday and Thursday. Tuesday and Thursday at 1 o'clock. That's what we kind of talked about before spring break. So we got Tuesday, Thursday, Tuesday, Thursday. Tuesday will be our last notes. We'll review homework number 30 on the 30th. Imagine that. Look at that. That's completion. We're completing 30 on the 30th. And then we are finished, guys. Okay? We're finished from there. Then we go into May. We basically have a little bit under 2 weeks to review for the exam. So to review for the exam, let me see if I can, there we go, zoom in a little bit for you there. So here's what I'm looking at. In order to get more practice in, and guys, I haven't asked too much of you guys throughout this whole quarantine process, so I'm just asking you to give me this kind of week right here. And it's really only 2 extra days than what you would normally do. Okay, so Tuesday and Thursday at 1 is normal. So I'm just asking you to do Sunday, Saturday, Sunday, May 3rd. So after our 30th exam, after our lecture, reviewing the homework on the 30th, the following Sunday, May 3rd, here's what I want you to do. I want you to, now, I did say that your binders will be able to pick up here on the 27th. So this whole week, just stop by the school sometime and pick up your binder with your exams. So then here's what I want you to do. At 1 o'clock, I want you to, it'll say practice exam 1, and then you'll flip the paper and it'll say part A. You answer it, set a timer 25 minutes, and then take a 5-minute break because you don't got to upload it to me or anything like that. Then do part 2, 15 minutes, and then write that down, and then we'll jump on here live at 2 o'clock. So at 1 o'clock, you start your test on Sunday, and then your 25 minutes, take a 5-minute break, and then do a 15 minutes. Okay, you don't have to upload them to me. I just want them there. And then at 2 o'clock, following this test that you take, I really pray that you guys would follow this procedure. Then at 2 o'clock, jump on here live. Okay, jump on here live, and then we'll review that both parts of the exam. We'll do the same thing on Tuesday the 5th. You'll go to your binder, practice exam number 2. You'll start it at 1 o'clock p.m. Now, I know some of you have work and stuff like that, but just do it. If you can't be at the live session, then just an hour before you watch the test, practice this, guys, just so you're seeing how you're doing. Okay, see, get the feel of it, get the comfort of what 25 minutes looks like. So we'll do that on the 3rd, the 5th. Practice exam 3, same thing. Started at 1, we'll meet at 2. At 7, and then Saturday the 9th, the 4th exam. Let's start it at 1 as well, end at 2. The only difference is I have Monday classes. So let's start the exam at 5 p.m. We'll go YouTube Live at 6 p.m. You take the test the next day at 1:30. And that is my plan going forward for you guys. Again, we've been served a mighty nasty curveball with just 2 questions on it. But I think this is normally... Well, I would give you about 5 practice exams with multiple choice, with everything. But I think this is our best response. Just give you what it's going to look like. Okay. Give me thoughts, questions, opinions on any of that, guys. Thoughts, questions, opinions on any of that. Cool. Morgan says it sounds good. Is May 20th your last, is that your last AP exam, Morgan? All right, Carter's good. Cool. Ian's good. Cool. Ben's good. Alex, you good, man? Have you already taken the test? And Alex has probably already taken the test and got a 5. Okay, cool, guys. You're all good. And then the beautiful thing is then after May 12th, we're done. We're done in terms of that. So I encourage you guys to keep staying on the grind. Keep doing what you guys are doing. I appreciate you. Know I'm here for you if you need anything. A few things I did want to discuss with you real quick. Hey, I hope you had a good spring break. Hope that all went well. Make sure you turn your stuff in to the folder or to me by Friday at 4 o'clock, okay? Again, on Tuesday, a bunch of you had already done that. Hey, our timing here is going to be, our time for classes will always be Tuesdays and Thursdays from here on out until we get to the practice exam week. It's going to be Tuesdays and Thursdays at 1 o'clock p.m., all right? Make sure you're staying up to speed. For those of you that have to work and do all that, make sure you're staying up to speed. Do not wait until the last minute to try to get everything. Don't be texting people and be like, oh, man, can I get number 26 homework from you? I never did it, you know. So please, please, please stay up to speed with all that. Something else I thought about doing with you guys that I thought would be really cool would be doing just a Zoom class. I haven't got to see you guys in a while, and I prefer the YouTube instruction over the Zoom. I'm not as familiar with Zoom. And I'm really familiar with OBS and YouTube and stuff like that, so that makes it a little bit easier on me. But give me a thumbs up if you guys would be willing, or you'd be cool with doing like maybe a Zoom, not like this, not tomorrow, but maybe next Friday. Maybe do a Zoom just so we can see each other. We can maybe get into debate about all this coronavirus and whether it's time to release the people and improve our community, or do we need to stay back and protect people? That'd be a good conversation. Give me a thumbs up if you'd be cool with like when meeting. It wouldn't be mandatory or anything, but maybe just meeting on Friday and having like a Zoom session where we can all see each other. We can all talk. We won't do any math, just pure talking and getting to see each other. Does that sound good to you guys? Give me a thumbs up on that. Morgan has a big conspiracy about Corona, so yes, please. All right, cool. Yeah. All right. That's good. Sounds good. I'll put that out on our schedule next week. Hey, one more thing, guys. If you have, I'll show you this on my phone here real quick. If you go to Canvas, okay, and if you go anytime you need anything for the class, you just simply go to Files, okay? Just go to Files, and everything is there that we have done thus far, okay? Including answer keys for the homework. So answer keys, it's just the answer. So you can kind of see there, like number 27, and you can kind of see your kind of answers from there. That's all there. And then also, when I complete something like 26, I completed the classwork and the homework. So if you wanted to kind of like go and see that, that's all there. And also with, if you need to print off what we just did, if you didn't go by the school, it's all right there under Files, and that's not the new one, but 27 is what we're about to do today. But that's all there, guys. The classwork and the homework combined together, if you need to print it at home, or if you need just access to it in general. Okay? Hey, now that I got all the preliminaries out of the way, let's jump right into number 27 classwork. And I think you guys had this one from the last packet, so I think we're good in terms of that. With that being said, let's jump into number 27, definite integrals, okay? Let me take myself out of the picture a little bit. I don't need to be that big. All right, so our first thing we want to kind of hit on here is definite integrals. Now, we talked about 26, chapter 26, chapter 25 is all about integrals, okay? Now we introduce definite integrals. Now, the course started off with defining the slope of a tangent line to a function. We developed a term for that concept, and we called it the derivative. All right, the slope of a tangent line to a function is the derivative. We will do the same for areas under curves. We define the term for the area between the function f of x, the x-axis, and the lines x equals a and x equals b as the definite integral. We write this integral as this right here, and we can read it a couple different ways. We can read it as the definite integral between x equals a and x equals b of f of x dx, or we can read it as the definite integral f of x d of x between x equals a and x equals b. We call f of x the integrand, and we call a and b the limits of integration. Okay? The limits of integration. So, if we just had an integral, it'd look like this. Right? And it would be some f of x d of x. Okay? That will produce, some antiderivative. Like, let's just say, for example, let's just say like 2x plus c. Okay? That will produce an antiderivative like 2x plus c. But and this is an infinite integral. But a definite integral, what we're doing today, a definite integral, there's one difference, and the difference is this. It has limits of integration. So you may see something like, and then it'll say like a number like 4 and 0 here, and then it'll be like something f of x d of x. But what you're going to get here is not a expression like 2x plus c, but you're going to get some numerical number like 25. Okay? So with definite integrals, we're going to get a number. Okay? With infinite integrals, no limits, meaning it just goes on forever, we are going to get an expression. Okay? Here, we get a number with definite integrals. So, this expression might not make much sense, but there is reason for it. It refers to the Riemann sum rectangles discussed in chapter 29, which we'll get to. In the figure to the left, we examine, I guess to the right here, in the figure to the right, we examine one Riemann sum rectangle. Its height is f of x. Its height is f of x, and its base is change of x, or the width. From our discussion of differentials, we know that the change of x is d of x. So f of x times d of x is just another way of specifying the area under the rectangle, or area of the rectangle, excuse me. Now again, this will make a little bit more sense in chapter 29, and we'll kind of get there. The definite integral represents the limit of the sum of these areas. The integral sign looks like a flattened S for sum as the number of rectangles approach an infinity, which is to say that d of x approaches 0. So the definite integral of f of x from a to b means the sum of the areas infinitely thin rectangles starting at a and ending at b, giving the figure to the right. Okay, so if we were to start at a and start at b, we could have an infinite amount of thin rectangles here. Okay, we kind of know that. So what this is calculating our area of this. Okay, that's what a definite integral is going to find. That's why we're getting some number up here instead of an expression. We're getting the number because it's going to basically calculate, it's the sum of the areas infinitely thin rectangles. So starting at a and ending at b. Note that the definite integral sign is the same as the indefinite. I actually said infinite up there. I meant indefinite, sorry. But it's the same sign as the indefinite integral sign, except definite integrals have limits of integration. This is intentional as there is a connection to the process of finding area under a curve and taking antiderivatives. This is discussed in chapter 30, which is what we'll end with, and that's the fundamental theorem of calculus. When you see a definite integral like this, you immediately think area under the curve of f of x. How much area is under the curve of f of x? However, you need to be careful. Okay, be careful because areas are always positive. Okay, definite integrals can be both positive and negative. When a, the bottom limit, and sometimes this is referred to as the lower limit, the upper limit. Okay, a is sometimes, like I said, a is called the lower limit, b is called the upper limit. So when the lower limit is less than b, the integral is being analyzed from left to right. So dx is a positive number. If f of x is above the x-axis, positive, our definite integral is a summation of positive times positive numbers, which is positive. But when the lower limit is greater than b, the integral is being analyzed from right to left. So dx is a negative number. If f of x is above the x-axis, it's positive. So our definite integral is a summation of positive times negative numbers, which is a negative. All those words are summed up in this chart right here. All those words right there are summed up in this chart. And I'll give you something, even just something easier than that you can automatically tell, hey, is it going to be positive or is it going to be negative? Okay? I'll give you something here in just a second that can kind of help that. Okay? So let's go back to the next page. So here are 5 simple rules, guys, which should make total sense to you if you think of the definite integral as being an area. Okay? So, the first one is this. If your upper limit and your lower limit, if your upper limit and lower limit are the same, then your area is 0. If you start at A and end at A, you've gone nowhere, so it's just a vertical line which has no area. So if your upper limit and lower limit are the same, your area under the line, the curve, whatever, is 0. Okay. Number 2, if we have, if it's opposite, okay, if you have A over B, okay, now normal it's B over A, okay, but let's say let's say it's B over A, but you need it to be the opposite. The only thing you have to do is just take a negative out and then switch them. From B to A gives a number. This will be a negative of the value if you start at A and end at B. So you may switch the limits of integration as long as you negate the integral. Put a negative sign in front of it. Okay? So anytime you have, and you'll this will make more sense here in a second, but anytime you have an upper limit and a lower limit, and you need it to be the other way, you can do that. You just got to negate the integral by putting a negative sign on it. Okay? The next thing, if you have a constant in your function, just move the constant out to the front of the definite integral. Okay, so anytime you have a constant like k, just move it out to the front. Number 4, if you have a definite integral that has a sum, you can basically just separate the two. The integral of a sum is the sum of the integrals. And then here, if you were to have something, we'll see an example like this, but if you were to be given something that has different numbers of upper and lower limits, then add the area from A to B to the area from B to C to get A to C. So if you need to find A to C, but it only gives you A and B and C, then just simply add those two together, and that will give you the area under A to C. Okay? So, skip right here real quick. I need to plug in my laptop. Give me 1 second. Okay, so give me a thumbs up. Give me a thumbs up if you're still with me. Give me a thumbs up if you're still with me as we get started in all of this. All right, Carter's still in here. Morgan's good. Ian's good. Okay, so below you are given the graph of f of x formed by lines and a semicircle. Find the values of the definite integrals. So we're not given a function. We're given a function, but we're not given it in its algebraic. It's giving it to us graphically. So it's wanting to find these integrals, okay, over here. All these integrals of this graph right here. All right. So let's start with the first one. Here's what this is saying. What's the definite integral of f of t d of t from 4 to 4? Someone type that in the chat box. We just talked about that. When your upper limit and your lower limit are the same, what's your answer? Good, Carter. 0. Good, Morgan. So it's 0. When your upper limit and lower limit are the same, it's just going to be 0. If you think about it, there is no area to get anything from because we haven't gone any distance. It's the same. Okay, looking at B. Okay? So here's what B says. B says, what is the definite integral? What is the area underneath the curve or the line from 0 to 1? Now, guys, you always start at the bottom. Always start at the lower limit and go to the upper limit. So this is saying from 0 to 1, which would be positive, which is going to the right. Okay? So what's the area from 0 to 1? Someone type that in the chat box. What would be the area under this? So imagine lines coming right here. And what is the area of this and this right here? Very good, Alex. 2. Very good, Carter. 2. Yes, 2. So I just want to make sure you fully understand what we're saying here. So if I zoom into my graph here, okay, if I zoom in, we're saying what's the area from 0 to 1? What's that area from there? And it would just be everything underneath that function at that point. And in that case, we have a 1 by 2 rectangle, or 1 square, 2 square, so your area is 2. Or 2 times 1, area is length times width, so 2 times 1 is 2. Okay? All right, going back over here to number 3. What is the area? What is the definite integral of the function of the graph from 1 to 3? So what is the definite integral from 1 to 3? Well, that would be from 1 to 3. And what it's saying is, what is the area under the curve? Okay? And that would be just this little triangle right here, guys. You can look at this a couple different ways. There's a full block right here, a half of one, so that should be 2. Or just take the area of a triangle. Take the area of this triangle right here, right? And the area of the triangle is 1/2 base times height, so the base is 2, the height is 2. So 1/2 base times height is 4. A half of 4 would be 2 as well. So C would be 2. You're fine, Alex. Okay. Let's look at D. From 0, what is the definite integral from 0 to 3 on the function? So that would be from 0 to 3. Well, that would be from here to here. So I'd have to shade in all of this. Well, we just found this rectangle. That was 2, and we found that to be 2. So 2 and 2 is 4. And it could be helpful to just we could like jot those down. So that's like 2. That's a total of 2 in there. That's a total of 2. We may have to erase it. I'm not sure. Okay? All right. Now let's go E. E is from 3 to 6. Okay? So the definite integral, what is the area under the curve from 3 to 6? All right? So from 3 to 6, notice that it's below. Okay? Now, so let's make a note here real quick, all right? So if it's above, it's going to be positive. If it's above the x-axis, your definite integral will be positive. But if it is below the x-axis, it will be negative. All right? So since this is below the x-axis, it's going to be, and notice here, we're just going from 3 to 6. So we're going from 3 to 6 right here. Okay? So, again, you may have to look at this kind of like this right here. So we have basically half of one here. And, oh no, that's 5, sorry. I thought, man, that's going to be hard to get. 5 and 6 right there. So we need to get all of this area right here is what we're looking for. Okay? So if you look at that, that's half of a triangle right there. So that's 1/2. And then that right there is a triangle. So that's 2. That has a side length of 2 and 1. So 1/2 base times height. So 2 times 1/2 is 1. And then plus that half would be 1.5. But it's going to be negative because it's below. Very good, Alex. Negative 1.5. All right. So we know that area right there is 1.5. Just kind of write it down. I'm just kind of writing it down with a pencil. Okay. So E was negative 1.5. Now looking at F, it says what is the definite integral from 6 to 3. Now, notice this is the first time. Notice this is the first time we've seen this. Our lower limit is greater than our upper limit. Okay, so that means that we are assessing it from right to left. Okay, which would be actually this way for you guys on the screen. So we're not going from left to right. We're not going 3 to 6. We're going 6 to 3. Okay, 6 to 3. So if you go to the right, if you go, this is just another note right now. If you go to the right, that's going to be positive. But if you go to the left, if you start right and go left, that will be negative, guys. So I think just knowing, if you can know this right here, which is pretty simple, it's pretty basic, it's pretty straightforward there. If you can know that, I think you should be pretty good. All right, so watch this. The area from 6 to 3 is 1.5. But since it's below the x-axis, it is negative. But since we looked at it from 6 to 3, from here to here, we went to the left, so that's negative. And a negative will produce a positive, so this would be 1.5. Again, we know the area is 1.5. We just figured that out from going from 3 to 6. But notice when we went from 3 to 6, we were going to the right, so that's positive. But it was below the x-axis, so it was negative. That's why E is negative 1.5. But on F, we went from 6 to 3, which is going to the left, which is negative. And it's below the x-axis, so that's negative. A negative and a negative produces a positive. Therefore, that's positive 1.5. Moving right along, looking at G. It's saying, what is the definite integral from 0 to 6? Well, from 0, notice we always start with the lower limit. From 0 to 6, what's the area of everything combined? From 0 to 6 would be from here to here. So that's 4 there and 1.5 there, right? But notice here we don't add everything because this is below it. So I would write it like this. From 0 to 3 was 4. but from 3 to 6 is negative 1.5. And then I add those together. Okay? And 4 minus 1.5 is 2.5. All right? So now let's look at h. So h is what is the definite integral from 6 to 10 of the function? So from 6 to 10, now this doesn't quite look like a circle. It kind of more looks like an oval, but we're gonna assume it's a circle, okay? Because it said semicircle in the in this right here, and it's saying what's the area of this? Well, you just need to know the area of a semicircle. The area of a semicircle, the area of a semicircle is just simply pi r squared h. Or no, sorry, not pi r squared h. I was thinking something else. Pi r squared over 2. It's the area of a circle divided by 2. We see here that the radius of this circle is 2 units. So that would be pi 2 squared over 2, which would be 4 pi over 2, which would simplify that down to simply 2 pi. Okay, questions? Ask me any questions right now, or you can simply... Okay, Alex says on G, would 3 to 0 be negative 4? Alex, that is correct if you were going from 3 to 0, but we're going from 0 to 6. So from 0 to 3, we're going to the right, so that's positive. We start at the bottom, go to the top. So we're going to the right here, so that's a positive 4. And then that would be your negative 1.5. Yeah, very good. Okay. Any other questions right now? If you don't have questions, give me a thumbs up that you're following on a little bit, that it's making a little bit of sense. No, you're fine, Alex. Okay, cool. All right, let's continue on to I. So I, all right. Now it says go from 10 to 6. What's the area from 10 to 6? Well, we just figured out from 6 to 10 was 2 pi. So from 10 to 6, we're just going to the left. It's above the x-axis. So going to the left is negative, and above the x-axis would be positive. So that should just be simply negative 2 pi. All right, going to J now. Okay, J. It's saying what is the area under the curve of f of t from 0 to 10? What is the area under the curve from 0 to 10? All right. So that would be from here to here. So what would that be? Someone type that into the chat box. What's the area going from 0 to 10? Good, Morgan. Very good, Morgan. 2.5 plus 2 pi. 2.5 plus 2 pi. Very good, Carter, as well. So good. So from 0 to 6 down here, we've already calculated that. That's 2.5. Plus just this area is 2 pi. All right. Well, how about this one then? What about the next one? What's K? From 10 to 0, going left now. That should just be the opposite, right? Negative 2.5 minus 2 pi. Yeah, very good. Yeah. And you may be saying, where are you getting the negative 2.5 from? Well, we're going this way now, right? So this would be positive 1.5. This right here would be positive since we're going to the left and it's below. That's a positive 1.5. And this right here, since we're going to the left, would be a negative 4. So it'd be 1.5 minus 4, which takes us to negative 2.5 pi. And then from 10 to 6 would be your negative 2 pi. Very good, guys. All right, continuing on. What about from negative 1 to 0? So from negative 1 to 0, that's going to the right, and it's asking what is the area under that? Well, if you look at this rectangle right here, that's 1 and that's 1. And then that triangle is a 1 by 2, so that would be a total of 1. So that should take us to 3 there. This triangle right here, including this upper portion, that, if we do an area of a triangle right there, that should give us a total of 3 there. All right, moving right along, guys. Looking at M. So from negative 3 to 0. So from negative 3 all the way to 0, what would our graph be then? Someone grab that answer. From negative 3 to 0. Someone grab that answer, calculate it, get the area, and go from there. So Morgan says 12, Alex says 11. And correct, it should be 11. Ben, you all right? Now, to say, okay, how is that 11? Well, if you think about this, I would erase this out right here. And just think you need triangles, guys. So I would just take this right here. I would take that block. We know that's 4. Then I would go up here and go 1, 2, 3, 4, 5, 6. That's a 6 by 1. So 1/2 base times height. Half of 6 is 3. And then this one is a 2 by 1, 2, 3, 4, which is 8. Half of 8 is 4. So 4, 4, and 3 would give me my 11. Okay? All right, how about from going to the left now. How about from 0 to 3? Well, since this is above, that's positive. But since it's going to the left, it would just force that to be negative. So negative 11. Okay? Going to our next one. It says from negative 4 to 3. Okay? From negative 4 to 3. Well, if you look right here, negative 4 to 3, that's going to the right. So that's positive. Negative 4 to 3 is positive. But it's below the x-axis, so that's negative. And as you can see, it's taken up a half. So we can just say negative 1/2. All right. Then it says, what is it from negative 4 to 0? Well, we found all this right here to be 11, right? So from negative 4 to 0 is positive, right? And that is our only thing that would be negative. So it'd be negative 1/2 plus 11, which should take us to 10.5. Okay, just a few more on here. Next, looking at, okay. Tim wants to know if you're giving those packets back on April 27th or whenever the date is. I'm assuming he's talking about all the homework. Yes, I'll put those into the binder as well. I'll put those into the binder if you want to tell him that. Okay, so continuing right along. And then of course you have to turn all this in too. So I'll make a way for you guys to come and get them. So, I'll try to make it as less trips as possible. Okay. All right. So looking at Q, and I'll grade all those on Friday when I go Friday to get them all. I'll just grade them all, put them in the grade book then. I guess that's tomorrow. I get my days mixed up. All right. So continuing on. Now it says from negative 4 to 10. Okay. So basically, what is the area of the whole graph here? Okay. What is the area of the whole graph here? What's the area of the whole graph? Well, we just found out that the area from here to here was 10.5, right? So we know it's 10.5. Yeah, very good, Carter. You got it. So it's just that 10.5, right? And then if we're thinking about this, that 10.5 plus the 2.5, which is the area from here to here, and then plus our 2 pi. So again, from here to here is 10.5. From here to here is 2.5. So 10.5 and 2.5 would make 13, and then plus our 2 pi. Okay, how about the next one? Try the next one out, guys. Try the next one out. Someone type it into the chat box once you get it. So this one is just saying, what's the absolute value of all this? Well, that would be like, we found all this right here. So what's the absolute value of 13 plus 2 pi? Just 13 plus 2 pi. Yes, correct, Alex. Yeah, very good. Very good, Ian. Okay. So now it says this. It says, what is the definite integral from negative 4 to 10? So we're going to the right now, of the absolute value of each, basically of the function. So we basically just have to make everything positive, okay? So if we're thinking about that, this would now become this half plus that 11 would make that 11.5. This and this would become 5.5. And then, of course, we know 2 pi. So that would take us to what? 17 plus 2 pi. So all the ones that were negative just become positive, and we just add them to the uppers limit there. Okay. And then going here now, guys, it's saying what is the area under the curve from 1 to negative 1? Okay, so from 1 to negative 1. Well, here's, let me kind of erase because it's kind of mixing us up from what we were doing. That's all right. So from here to here, what is our, and I'm going to kind of break it down into a square and triangle. So I know that's 4, and that's a 1 by 2, so that would be 1. So I know it's 5 here, okay? But what I'm going to do, I'm going to move that constant out. Just following that rule up. If you ever have a constant, move it out. I got 1 and negative 1, and then of f of t. And then I know that f of t, the area between 1 and negative 1 is 5. But pay close attention, guys. We're going from right to left this time because 1 to negative 1 is going to the left. So it's going to be a negative 5. So negative 5 and then times the negative 2, which was the constant, should take us to a positive 10. All right, give me a thumbs up on that. Give me a thumbs up if you guys feeling pretty good. If you're feeling pretty good about that. Carter's good. Cool. Ben's good. All right. Let's go to the back side. Okay. So here we go. It says, suppose that the definite integral from negative 2 to 5 of f of x dx is equal to 18. The definite integral from negative 2 to 5 on g of x dx is 5. The definite integral from negative 2 to 5 on h of x d of x is negative 11. And the definite integral from negative 2 to 8 on f of x d of x is equal to 0. Find the following. Okay? So we're just going to find basically all of these here. So it says the definite integral of negative 2 to 5 f of x plus g of x. Well, it's actually given us both of those. From negative 2 to 5 and negative 2 to 5 for f of x and g of x. So we just need to plug in those values. 18 plus 5 is 23. Michael Jordan. 10-part documentary comes out on Sunday. There you go. I just saved your life. Michael Jordan 10-part documentary comes out ESPN on Sunday. So I just saved a life right there. We hadn't watched any sports, but they're dropping probably hopefully this is a really good documentary. I assume it's going to be. All right, going to number B. So f of x, g of x, and minus h of x. Yeah, I know, right, Morgan? So, and it's notice that it's given us each one of those integrals, each one of those definite integrals for each one of these. So we just need to say 18 minus 5 plus 11. Minus would be plus, and that should take us to 24. All right, over here we have from negative 2 to 5 with 4 times g of x dx. So what do I need to do with that constant? Someone type that in the chat box. What do I need to do with that constant? Not flip it to an actually one second. Oh, good call, Morgan. I almost didn't catch that. All right, yeah. So Morgan is actually correct, and you are also correct, Carter. I almost didn't catch that though. Thankful that Morgan's here. So notice here that this is -2 and 5. Okay. Now everything it gave us was -2 from -2 to 5, -2 to 5, -2 to 5, but this is from 5 to -2. Okay. So as Morgan said, we need to flip this integral right here. That's part of those rules that we can follow back there on our rule sheet, that if you ever need to flip it, just negate the integral. Okay. So it looked like this. Let's negate the integral. Let's move the 4 out, and let's change this to 5 and -2. And then that would be g of x dx. Very good, Morgan. And again, that's going back to this rule right here that says anytime you have like AB, but you need it the other way, just negate it and flip it. Okay? And then from there, we know that -2, the integral of -2 to 5 g of x is equal to 5. So then we just say -4 times 5. And that equals -20. Okay, D. I'm going to D. It's saying from -2 to 5, g of x plus 2. Now, unfortunately here, I cannot say g of x. I just can't plug in a 5 and say 5 plus 2 is 7, guys. I can't do that because I don't know the limit from -2 to 5 to 2. Okay, so what I need to do is to rewrite this. Again, the sum of integrals is the sum of the integrals, right? So I would just need to rewrite it like this. So -2 and 5. And I just need to say g of x d of x dx, and then plus, same thing over here, -2 to 5 with 2 being right here, dx. Okay. So now here, g of x dx is equal to 5 on the definite integral -2 to 5. So that's 5. So I say 5 plus. Now watch this. This is a constant, okay? This is a constant right here, so I need to move it out in front. So that's going to be 2 times, and then really, guys, what I'm left with here is this. From -2 to 5 dx. So really the only thing there is a 1, and 1's a constant, so we can't really even say that. So in this right here, when you have an integral with the function like really not being there, it's just dx, this right here is going to be equal to the distance between these two numbers. Okay? And the distance from -2 to 5 would be +7. Okay? So when you have something like this, okay, the definite integral of -2 to 5 in terms of x, it's just going to be the distance between those two numbers. So here it would be 7. Because we have nothing to go off of, so our distance, we just put our distance there, and then 5 plus 2 times 7 would be 19. All right, looking at E. E's same type problem, so let's rewrite it. From -2 to 5, f of x dx. And it's minus this time. -2 to 5, 6 dx. And you could like go ahead and write that with the 6 out front. That would be completely fine as well. So we say here, -2 to 5, or actually, we don't have to use that. Is just f of x would be 18 minus 6 times, and again, that would just simply go to this, -2, 5 dx, and it's just the distance between those two, which would still be 7. So that's 18 minus 42, which would be -24. All right. How are we feeling about that? Give me a thumbs up, making sure you're still with me here. Morgan's here. Good. Good, Ian. Okay, cool. All right, very good. Moving right along, looking at F. So with F, we have a 1/2 here, guys. So what we need to do, we need to push that out front. So we'll say 1/2. And then I can go ahead and mix that up, and I can say h of x d of x. And then plus, from here to there, -2, 5, 5 dx. Okay, so bring my 1/2 down. From -2 to 5, h of x is equal to -11 plus 5. Bring that 5 out front, and then the distance between these two is 7. So I have -6 plus 35, or excuse me, -5.5. So -5.5 plus 35 should be 29.5. Or 59 over 2 if you wanted the decimal or the fraction. Either one will work for me. All right. So looking at this, looking at G. So G says from 0 to 7, h times the quantity of x minus 2 dx. Now, we don't have anything, we don't have a definite integral that gave us 0 to 7. So that presents a little bit of an issue because we don't have anything like this. up there that has an answer. But there is something here that tells us something, okay? And it's this whole x minus 2. So this hx minus 2, it actually shifts the curve 2 units. Now, this would be going back to like algebra 2, going back to the basic of functions. If you have something on the inside and it's minus 2, which way would that shift that graph? So if I had like x minus 2 squared, that's x squared, but x minus 2 shifts it which way? X minus 2 shifts it to the right or to the left? Anybody remember that? Yeah, very good, Carter. It shifts it to the right. It's opposite. Okay, it shifts it to the right, so it's opposite. Now, let me explain that in a little bit more, maybe where you can understand it, just so you see where we're about to go with this, okay? So let's say we had a x-axis right here, and we have, I let the dog out, babe. -2, I let him out once today. 1, 0, 1, 2, 3, 4, 5, 6, 7. Okay? So let's say we have this graph right here. Okay? Now, I don't know what this function looks like, so I'm just going to draw a curve from 0 to 7. Okay? So that's just your curve from 0 to 7. But what this x minus 2 tells me is this, that graph has been shifted to the right twice. So if it's been shifted to the right twice, it's gone this way right here 2 times. So technically, that would be there, and this over here would be like right here. It was shifted that way 2 times. Okay? So technically, this h of x, this would kind of be h of x right here. And this would be h of x minus 2. It's been shifted to the right twice. Okay? So just kind of showing you the visual of that. Now the purpose behind the visual is that now you see this right here. That h of x, and I'll say the 0 to 7, that h of x minus 2 dx is equal to the definite integral from -2 to 5 h of x d of x. And of course that was given to us up there, so that would be -11. So again, this would be the graph of h of x. This is h of x being transformed right 2 units. Okay? So technically, if we take it back 2 units, we take it back to h of x, and we can lose the x minus 2, and then we're sitting here good, because now our limit is from -2 to 5, which is what the problem gave us at the top. All right? Okay. So looking at h, what does that x plus 2 do to g of x? Can someone tell me how that shifts that? So g of x plus 2 shifts the curve 2 units what? Good, Carter, 2 units left. Okay? So, and now easy trick to remember this is, whatever sign this is right here, whatever this is right here, just put it to those two. So 3 plus 2 is 5, or let me write this out properly. That's 3 and negative 4. G of x plus 2 dx is equal to, right here, that, you just add 2 to that, you add 2 to that. Notice over here, we subtracted 2. Now again, on the graph, that shifts it the opposite way, but technically putting it here, it's just like taking it from whatever that is. So 3 plus 2 is 5. Negative 4 plus 2 is negative 2. And then we're just looking for g of x, which would simply be 5 here. Same thing over here. 0 minus 2 is negative 2. So it's just kind of a little shortcut you could follow. Okay, going to this next one, going to I, we have the definite integral from 5 to 8 f of x dx. Now, I have the definite integral from negative 2 to 5, and I have the definite integral from negative 2 to 8. But I don't have it, let me explain that again. I have from negative 2 to 5 f of x, and I have from negative 2 to 8, all right? But I don't have from 5 to 8. So as you saw in the last, in those notes, which would be right back over here, if you have A to B and B to C, those combined will give you A to C. Okay, so we're looking for the middle. Okay, we're looking for the middle here between 5 and 8. So what we simply need to do is we need to say, okay, this right here, the definite integral from 5 to 8, f of x dx is equal to the definite integral from negative 2 to 8, f of x dx. And then with this, we wouldn't add because we're subtracting the big distance from the shorter distance. So minus, and then we would go negative 2 to 5, f of x d of x. So the example on the, or the formula in the notes says if you have from A to B, and then you have B to C, then those two combined will give you the length. Okay, but what we have here is it's looking for the middle term. It's looking for from 5 to 8. Okay, and what we have is from negative 2 to 5 and from negative 2 to 8. So we would subtract the difference. We would subtract the two. Well, the function here would be 0. The function here would be minus, and that would be 18. So that would be equal to negative 18. So technically speaking here, we would say the definite integral from 5 to 8, f of x dx is equal to negative 18. Okay, now that's going to help us on this next problem. This next problem says the definite integral from 8 to 5 times quantity of 1 minus f of x dx. Okay, so with here, we don't have 5 to 8, but we do have, we don't have 8 to 5, but we do have 5 to 8. So remember, I can flip this, right? I can flip this integral and put 8 up here and 5 here. oh, sorry, I can flip it, put 8 in the upper limit, 5 in the lower limit, okay? And I can simply say here with this is I just have to negate this. Put a negative there, right? And I could rewrite that like this right here. 1 minus f of x dx. Okay. Now, since I'll just work it this way. A trick that I could do right here, guys, is because think about this. The end result is just going to be flipped. Everything's going to be divided. So I could technically almost like distribute that negative into both of those and change those signs and find it. Or I can leave it on the outside and that won't hurt anything either. So let's just go about it like this. So it'll be negative 5 to 8. And remember, we're going to split this up right here. So it would be 1 dx and then minus, same thing here. The minus comes from right here. That negative staying out there with that integral. 5 to 8 of f of x. F of x. Well, no, actually, let me rephrase that. There would be another negative here because I'm doing the integral of this and this. So that negative would have to stay with both. That's why if you went ahead and distributed it, it would work as well. So the minus comes from here, but this has to have a negative because it had a negative from the beginning up here. Okay? So the negative of this, that's a constant. So think you just got to move that out. And when you have a constant, it's just the distance between here. So that would be 3. And then the negative would come down. So negative 3. And then minus, and we know that's going to be a negative there, whatever that is. And then the definite integral from 5 to 8 is what we found up here. And we found that to be negative 18. So negative 18. Those two minuses would turn to a plus. And then I have negative 3 minus 18. And that would take us to negative 21. So don't make the same mistake as I did. Make sure you always, if you negate the integral, it has to follow the integral wherever you put it. Okay, I almost made that mistake. Like I said, the other way you could do this would just be because it's going to impact both of these, so you can almost like distribute it in or change the signs. All right. Okay. Moving right along to K. Looking at K now. So K from 1 to 8. F of x minus 3 plus 3 dx. So keep in mind that this x minus 3, you got to catch these, that x minus 3 shifts it to the right, or excuse me, to the left 3. To the right 3. Right 3, yeah, sorry, right 3. Okay? So that shifts it to the right 3. So technically, I can subtract 3 from both of these. So if I do that, I'd get this. 5 and negative 2. If I take out that right 3, that would change my limits here to f of x plus 3 dx. And then you all would see that that would do from negative 2 to 5 f of x, and then plus from negative 2 to 5 on 3 dx. try to get a little closer so you guys can see. Sorry. Okay. So from here, from -2 to 5, f of x is 18. Plus, move the 3 out. And then that would just be, when you take that 3 out, it would just be the integral of -2 to 5 dx. So it's just the space between those, which would be times 7. So 21 plus 18 is 39. All right, last one like this. So we have this right here. Let's go ahead and move that 2 out front. And then from there, once we move that 2 out front, now notice that 2 is just with that one right there. Okay, it's just with that. So move the 2 out front. That -4 is to the right 4. So I can take off 4 from both of those. So that's 5 and -2. And then 5 and -2 f of x dx minus that 5 and -2 with the -6 dx. Oh, it wouldn't be -6. It would just be 6. Sorry, the minus goes there. And the reason 2 doesn't go, and you may be saying, well, hey, the negative followed this over here, okay? And that's because we split that up, but this is a constant, okay? We had to negate the whole thing over here, but this, we're just pulling that constant to the 2, so it's just, it's out there, okay? So you just have to put it with that 1. So -2 to 5 f of x is 18, so that's 2 times that 18. And then minus, and then that would be a 6 there. Move the constant out front. And then the distance between those is 7. That would be 36 minus 42, which would be -6. All right, last 4 problems of the day. These should go by pretty quick. It says evaluate the following by making a sketch of the function. Okay, so we want to know what's the area under the curve or line of from -3 to 3 on x plus 2. Okay, so x plus 2, the y-intercept's 2, the slope is 1. Right, y equals mx plus b those days. Wouldn't it be nice to go back to those days? Up 1, right 1, up 1, right 1. Up 1, right 1, down 1, left 1, down 1, left 1, down 1, left 1. And we'd be making a sketch like that. Okay, now I'm going to use my pencil here. It says find, or it just says evaluate the definite integral. That definite integral is saying, hey, where on this line is it? What's the area under the curve from -3? So that would be here to here. So what is all that area right there? So what's our area under all that? Okay. Well, as you see down here, that is down 1 and over 1. So 1/2 of 1 would be, and since it's below, it would be -1/2. And then here we have 1, 2, 3, 4, 5. That length is 5, and that is 1, 2, 3, 4, 5 as well. So that would be 5 times 5 is 25, and then half of 25. So that would be 25 over 2. That would go -1. Since we have like denominators, we can add. -1 plus 25 would be 24. 24 over 2 is equal to 12. So this is equal to 12. Give me a thumbs up if you're following me on these type problems, what we're doing with them. Give me a thumbs up. Cool. Okay. Going to this next one, it says the absolute value of plus 2. Now again, what we did up here, that whole plus 2 on the inside shifts the absolute value. Remember, absolute value is just the V. Shifts it to the left 2. So here, and then absolute value is just up 1, right 1. Up 1, right 1. Up 1, right 1. Up 1, right 1. Up 1, right. Up 1, right 1. Over 1, up 1. I think that's what we have there. Okay? Now it's asking from -3, which is right here. So this and 1, 2, and all the way over here, all this. All right. So again, that's a 1 by 1 side triangle. That side has 1 and that side has 1, so that's 1/2. And then this has 1, 2, 3, 4, 5 sides, and that's 5 sides. So 5 times 5 is 25. The area of a triangle is 1/2 base times height. So 1/2 of 25 would be plus 25 halves, which would take us to like denominators, add the numerators, 26 over 2, which is equal to 13. Okay? All right, looking at number 3. So it's saying the absolute value of x plus 2, the absolute value of all that. Well, the absolute value of x is just x. So that's just like looking at the absolute value of x is x. Oh, okay, I see what they're saying. Okay, so really here, we don't need to look at it that way. We need to look at it like the absolute value of x plus 2. And that looks extremely confusing, okay? But here is the way that I'm going to rewrite it just so we can kind of hopefully see it a little bit better. So what is the absolute value of this right here in the center? Well, absolute value just changed stuff to positive. So that would just become this, the absolute value of x plus 2. So it goes from here to here. All right. Now that plus 2 is on the outside, it's not on the inside, so plus 2 goes up 2. And then we just graph absolute value of x from there, which is just right 1, up 1. And then same thing over here. I just want to confirm my graph. Just to make sure. Okay, yeah, we're good. Cool. All right. So then from there, it's wanting to know the area under the curve from -3 to 3. So from here to here. Okay? So the way I would look at this is break it down into a rectangle and 2 triangles. Okay? The rectangle goes, that's a side length of 2, and a side length of 6. So that's 12 area there. This has a side of 3 and a side of 3. So that's 3 times 3 is 9, but half of 9 is 4.5. But then you have 2 of those, so that's really just plus 9. And that would be equal to 21. So 2 triangles, 2 3 by 3 triangles together, think that would just be 1 square. So a 3 by 3 is 9. So that would be equal to 21. Okay, last one. So again, you can kind of think about that absolute value of 2 minus the absolute value of x, absolute value. So the absolute value of all of that. Again, this one gets a little bit tricky, okay, in terms of what it looks like, just because you're taking the absolute value of that minus x. So you'd think that would change that to positive absolute value of x, which shifts it up 2. We'll just graph this in the calculator because I don't want to confuse anybody in what this is asking us to do. So let's go math absolute value of 2 minus the absolute value of x. So let me zoom out of this real quick. So zoom 6. So what's happening here is it's going from -2 and it's going up to 2 and it's going to 2. It's going down, down, and then it's going up after that. And it's going up to just, there we go. Okay? So that negative there is going to play some games with some stuff. So a negative absolute value flips it down, so it reflects on the x-axis. But then technically, since it's all the absolute value, it continues to go up. That's a very unique function. Okay. So from here, we just need to find from -3 to 3. So in this, that, and that, that's a 1 by 1, so that's a half. And that's another half over there, that would be. And then from there, we could say this is a triangle, a 2 by 2 triangle. So that would be, that has an area of 4, but then you half it, so that's plus 2, and then that one's 2. So that would give us a total area of 5. All right, guys, that completes number 27. Number 27 notes. You got the homework that simply follows it right here. Just going through there, working all those type problems back there. It has a front and a back. That's going to be due. That it seems to have several problems on it, but that's going to be due to you guys on Tuesday. Okay, so when we meet again on Tuesday, you will need to have that finished and completed. All right. Are there any questions to me about anything? AP test, the homework, the classwork, when we're meeting, any questions of me at all? If you don't have any questions, give me a thumbs up. If not, type the question in. I'd be happy to answer it. Okay, Ian's good. Carter's good. Alex is good. Ben is good. Morgan's all good. All right, guys. Hey, if you don't have any other questions, Hope you guys have a good weekend, good time off. Hey, we won't, as you've seen the schedule, we're not going to meet on Fridays except for Zoom. I'll send you out like a link and stuff for Zoom next week. So be happy to see you there. Feel free to come. Feel free to send me an email with any questions, and I'll get your grades updated on Friday. Again, any questions, shoot me an email anytime. If not, you guys have a good day. We'll see you guys. See you, Alex.